Department of Mechanical Engineering. Today we are going of a lecture 5 on a manufacturing process of a MIG welding and a plasma welding. So here the basically, if I say of a MIG welding, we can also say that the MIG welding also call it as a gas metal arc welding and the plasma arc welding. Today we are going to discuss about that one. Okay, so first we start with a MIG welding. So MIG welding is also known as a gas metal arc welding here. So the MIG welding, if I say of a MIG welding, so MIG welding means of a metal inert gas is also similar to the of a TIG welding. So in a TIG welding, we are using of a previous class we have discussed about the TIG welding means we are using of a non-consumable of electrode, but here we are using of a consumable of electrode. Processes both are same here. TIG welding and the MIG welding. In TIG welding, we are using of a non-consumable of electrode here in a TIG welding, and in a MIG welding, or we can say the gas metal arc welding, we are using of a consumable of electrode. Means we are saying in terms of wire we are saying. Okay, so now we start with our means content of a what is a MIG welding, what is a MIG welding of a process, and what is a MIG welding of a diagram here, applications, advantage and disadvantage. In the same manner we are going with the plasma also. Now coming to the MIG welding. So we just now I said of a MIG welding is also known as gas metal arc welding. Okay, and here the which is take place of a high deposition rate and welding process here, and here we are using of a metal wire. Just now I said of it, we can also say that is a feed wire also we can say here. Okay, for a spool for welding thing. Okay, and it is a semi-automatic welding process also we can say the MIG welding. If I say of a which is a viva question is which is a more faster, TIG welding or MIG welding? In class I will say which is the faster. This is a means it will be a comes in a gate question also sometimes. In competitive exams also we will get which is a faster, MIG welding or TIG welding here. Okay, coming I will say. Now coming to the MIG welding of a process here. Now the MIG welding process here. If I say of a MIG welding, so the process means what are the things are taken place here in MIG welding? Means just by using of a MIG welding of a process here, we are using of a trigger of a control to a wire feed of a spool, same just like of a TIG welding only. And basically we are using of electricity to produce the heat same way, an electrode to fill the joint here, and the shielding gas to protect the atmosphere from the weld. Same in the TIG welding also. We are just TIG, we are comparing with the means of a MIG welding here. But instead of a non-consumable electrode, we are using of a consumable. See, this is a from the this diagram. See, this is a here. Yeah, this is a wire we are using. Now we are coming to this is a what type of a wire we are using here and everything from the diagram. Okay. See here now compared to this one. Now from the diagram, see here. See here. Now the MIG welding, what are the things are taken place here? First thing is we are using of a base metal and a power supply. Power supply, one is a ground cable, another is a electrode is a taken place here. Okay, and we have a connection to the inlet of a gas, and the molten pool is taken base metal, same as like of TIG welding. Okay, now here what is going on here? If I say of a here in a MIG welding means here we are using of a high voltage for basic points we are not means we are using of a high voltage we are taking place, DC supply is taken place here, and consumable of a wire we are going on. So according to that one we are also going with the means of a the electrode. The very basic point we have to know that one here is a electrode is connected to the positive. Electrode is connected to the positive terminal here. Okay, and here the workpiece is connected to the negative terminal here. Okay, we have to know that one. So this is the very basic point here, and in the same manner, let's we go with our principles. Okay, now what is the working principle of the our this one means here we are using of a by using of our MIG welding of a process means what happened here from by using of this one, see here, means I am giving a connection of a power supply. One is from the negative terminal to the base metal here and positive terminal to the electrode here. So here electrode when I am giving here, okay. So there will be having a connection along with that one inert gas here also. Okay, inert gas I am giving a one more connection to the here of a electrode here. Okay, and contact tube and a no, gas nozzle, arc and the shield here. So what is going on here means just is a means the filler material, the arc and the weld pool are shielded by inert gas. Means I am saying here the filler metal. Okay, inside that one there is a I said now a previous of a slides. Okay, means the filler metal and the arc and the weld pools are shielded by the means everything with the gas here. Okay, the shielded filler metal and here is the arc and the here is a weld pool are shielded by the gas. Inert gas means what is the use of inert gas? We are very well known that which is protect from the atmosphere here. Okay, and which is also depend upon the work material and the shielding gas may be a what type of a gas just know from the big acid of a argon and the helium, but here we can use of a same argon, helium and carbon dioxide. Be careful. What I am saying here is when I am saying inert gas, I am using of a here inert gas, I am using of a argon, helium and carbon dioxide is where we are using, just we will discuss here. Means here argon for non-ferrous material. Means argon I am using for the non-ferrous of a material I can use this, and for the helium for the copper and the carbon dioxide for the ferrous material. Okay. And okay, and carbon dioxide gas is useful for the shielding gas also sometimes here. Okay, which is protect from the atmosphere. Means here everything means argon, helium, carbon dioxide. Means if I'm saying of a argon gas, argon is we are using for the non-ferrous of a material here, and the helium for the copper material we are using, and the carbon dioxide we are using for the ferrous of a material. This all gases we know very well. This is protect from the atmospheric, which is so that there will be a no contamination can be taken by at the welding zone. Means here if from the atmosphere what happened there will be having a contamination can be taken place if you're not using of this gases here. So to protect from that one gases atmospheric contaminated so that it does not damage our welding zone, so we are using of a inert gas, same just of TIG welding. Okay, now coming to the principle here, we are very well known that the metal inert gas also this process also will refer just now I said of it means this is also can be known as what is the name I said of here is a gas metal arc welding also we know that one. Okay, both are MIG and the name of a gas metal arc welding is same here. Okay, so here what we are using as a base metal here or we can say that is the electrode is a consumable here. Bare electrode is a consumable means here it is act as a wire we can say. So okay, this is a what happened continuous of a wire is a which is a feeding. Here I am using of a continuous of a wire is a feeding through the welding torch. This is connected to the welding torch. Means of a bare of a electrode of a wire is connected to the welding of a torch, and it is a just like it is a gun. Okay, and with the help of electrical motor and the feed roller also we can say electrical motor or sometimes a feed roller we can say here in between. See here this is a feed roller. See this is a the two rollers are there here one and here two. So it can be a with a can be a connected with the electrical and feed roller we can also say here. Okay, now coming to the here. Okay, the electrode and the workpiece are connected to the uh, electrical supply. We are very well on this one. Okay, the electrode and the this we can say of it this is a gas. Okay, not gas can be connected with this electrical connection here. Okay, now with the electric this gas from the cylinder is supplied through a nozzle. You know this is a gas with a nozzle here. Okay, so here what happening supplying of it through a nozzle to form a protect of a shield. You know this is a gas which you are using of a argon, helium or carbon dioxide is which is what for what we are going it is protect from the atmospheric pressure here. Means which is protect from the atmospheric here. So that it should not be contaminated with the workpiece. It should not be contaminated of this welding area here. Okay, And just now I said of a very careful that now the very important point here, we are using of a direct current, because I said of a here is a direct current I am using, means here reverse polarity can be used here in a MIG welding here. Reverse polarity is used in a this one, because the terminal I have given a negative to the base metal and the positive terminal to the electrode here. So reverse polarity is taken place in a most of the thing we are going for the MIG welding here. But for the DC straight polarity, we can use of a what happened is sometimes we can use here, not regularly we are using of a DC of a direct current of a straight polarity we are using of a sometimes. Okay, but AC is not used in this MIG welding. Be careful. Is a question that sometimes they will ask you. The AC is not in MIG due to a unequal rate of electrodes wire here. So what happened? AC we are not using here. AC current we are not using in a MIG welding. Okay, in this one. Now here, if I say of a now I said of a last just of a one question that which is faster, which is more faster compared to the TIG and the MIG. Sometimes they will ask you. So the MIG welding is more faster compared to the TIG and other welding process. It's clear. MIG is very fast, or we can say very rapid compared to the TIG or other welding process due to the continuous feeding of electrode. Due to the continuous feeding of electrode, we are saying that is a TIG MIG welding is more rapid or more faster compared to the TIG and other welding process here. And deeper penetration of a weld also we can say here, and better quality also we will get here. In the same manner, welding can be done in all position here also. Just like of a TIG, we can go with the all position here also. Okay, shooting of a feeding roll and this one. See from the diagram also, this some given some angles here. So in the meanwhile, what happened? What is the very disadvantage of this one? Initial cost is very high. Setup is very high. That is a very drawback here, and it is not suitable for operator to do in an outdoor also. We can go with the TIG welding, but we can't do the sometimes we can do. But here, MIG welding, we can't go with the outdoor of a process. So that is a because it will damage the field. So this is an application. If I say it can weld of a carbon, alloy steel, stainless steels, heat resistant, or magnesium alloy, copper, aluminum oxide, anything. Special techniques also it can go ahead. Is a widely, especially the MIG welding is used in a aircraft and automobile of a industry. Now once again, okay. So here what happened here? See from the diagram here, the from the power supply, it is a giving a connection from to the workpiece base metal, another to the electrode here. Electrode means of a bare of a wire here. So with the what happened, there will be inert gas. We are using a argon, helium, carbon dioxide. If I'm saying of a gases like a argon, we are using for the non-ferrous of a material. For the helium, we are going for the copper material. For the carbon dioxide, we are going for the ferrous materials here. So here it is connected to the this of a bare wire electrode of a, and when there is a process going on, why it is using for the gases means to protect from the atmospheric air. So here this process can be carried out here and is a more faster compared to the TIG welding. From the diagram here, now see the same diagram here, how it can make of a process is a means same thing. I have continued here, feed wire, consumable electrode, arc, and the shielded gas. So molten weld pool, everything. Once again, I have seen the fig from that one. I have on here how the DC supplier can be taken place, means reverse polarity. Okay, so this everything can be taken place here. We can use of a argon of a okay. And once again, I have one diagram here. The weld metal, arc, contact tube, gas nozzle. We can there's no consumable of a electrode here. We are using of a very important point. We are using of a consumable electrode here, and in the sense of a bare wire, we can say here, and a gas shield which is protect from the atmospheric air, weld pool, and the present of a parent of a material here. And the welding variables and the parameters, if I say of a electrode extensions here, means of a wire feed of a spread is a controls the fusion and the penetration here. and the travel speed and control the depth of penetration here, gas flow rate here, protect weld from the atmosphere also is very important. We know that one, because if you are not protect from the atmosphere, what happen? It will get of a damage here. So this other thing is very important in this one. So even we can go with the see here, uh, means here voltage of a setup on the welding machine, control the arc length, and here from the tilt angle we can say of a back or a forehand should be in, means here we have to see that one tilt angle, means there will be angle should be there not greater than of a 15 degree from the perpendicular. We have to see that not more than of a tilt angle 15 degree, but we can go with all directions here, but the all position we can say, but tilt angle should not be more than of a 15 degrees. We have to maintain that one. So here the some of a means different types of a means we are saying of a techniques we are using here, means push technique, gun perpendicular here, and the drag and the means here angle we are making that one here. So the main just now I said of it not more than of a tilt angle more than of a 15 degrees here. So we are maintaining electrode of a direction head of a bed, means electrode we are using of a 10 degrees, sometimes perpendicular directly of a right direction, and the left direction we can also with that pointed into a back into a bead here ahead of a bed, means we are not exceeding 15 degrees that one. Okay, and if you are saying of a here of a push type, means of a ahead of a means right angle. So what happened? We are using a push technique. We are using and perpendicular, that is a gun perpendicular. We are saying we can say here of a drag or a pull technique. We can so say here. Okay, these are the angles to that one. Direction of a welding also we can. Now the just now I said of a applications, automobile and aerospace and aircraft. So these are the very application can be, we have seen from the diagram also what is the before and the after that one. How can the MIG welding can be taken place here? Automotive of a repair, overlay of a resistant coating here, and a welding repair pipes here, and a rebuilding of a equipment, reinforcement of a surface of a worm, railroad of a track, and we can say aircraft, and automotive is a simple thing of a automobile here, and we can say refactory of a material, means reinforcement of a that can also be taken place here. That's everything in the applications of this one. Advantage, just now I said advantage is a high quality and produce master and produce much faster, means very rapidly take place here, and compared to the TIG welding and other process here. And flux is, we know that one, the inert gas is itself is a protect from the atmosphere. There is a no use of a flux here. Last time also we have discussed about in a TIG welding, same thing here as well. There is a no chance of a interrupt of a slag in the weld metal, and result in a high quality of a welds also can be taken place. And the gas shield protect means arc, so that there is a very little of a loss of alloying of element, and the minor of a well of a spatter is produced, sound can be produced very minor. And even the MIG welding, because what happened, the wire feed rod is there directly, it's going and it's forming, and the due to melt, and what happened, it will get joining can be taken place in the this one. So this is can be take place here, and even we can go with the hence MIG weld can be operated several ways of including a semi and a fully automatic also. What is a very disadvantage? Just now I said of a disadvantage is a means equipment cost is very high, and one more thing I said of a we can go with the outer, means outdoor we can do that one. So here cannot be used in a vertical or a overhead of a welding position because of a high heat of input and the fluidity of a weld, but also can be taken place here, and the equipment is complex, means that is the cost is also very high, setup is very high, and the difficulty of a install that one, and outdoor also is very difficult because it will be a means may break the shield. Due to that one we are going with the outdoor. Now coming to the plasma is very important point here is a, now next is a plasma. If I am speaking about the plasma, see here from the diagram what is the means of a plasma here. Plasma arc welding, the plasma, another name, another we can say that the plasma arc cutting also here. Okay, but we are studying about the plasma arc welding here. So if I am saying of a plasma arc, so what are the things are going on here? Okay, so from the there is a torch is there. Okay, from this diagram we can see from the this is a torch is there. Okay, see this inside that there will be having a electrode is there. Inside this one there will be having electrodes here. Okay, see this is a plasma. This portion is act as a plasma. So what is, now we are studying what is the mean of, what is actually this plasma, how the plasma get generated here. Now the in a coming class we will discuss this one. Okay, so here the plasma is very important point. Is a plasma means here, if I say such a plasma, how the plasma gets generated, what is a plasma actually means, which is a hot ionizing of a gas we are saying. If I'm saying of a hot ionizing gas, means here the gas and heating, means we are heating that gas, means hot ionizing of a gas. If I say the gas gets heated, if a gas gets heated, what it will come, it will forms of a means ions, electrons, or it exhibits of a atoms here. This all things means of a ions, electrons, and atoms. So that it will get a, then it will forms of a nothing but a plasma. Means we are heating the gas in a very big temperature, means to get the plasma. So it may be a 25,000 degree to a 30,000 degrees Celsius. We are heating that one, that gases here to form the plasma. See this one. To form the plasma. It's clear? And this is a out of this one. So here in this portion we'll get this one. Okay, the plasma. So from now, see here, the content we are going to be a means of a introduction, keywords, plasma, arc welding equipment, how it works, types of plasma, modes, effective, various parameters, advantage, disadvantage, and application. If I say of a here from the diagram, okay, first we'll go with the what is actually the plasma of a from this one. So, okay, first we'll go with the introduction. So the it is introduced in of a welding industries in 1964 only. Means brings in a better control of a arc welding process in a lower current of a range here, and brought to industry by providing an arc advanced level of control, because we can control easily here. Okay, so here we are using of a means of a inside that one. Okay, we are using of a some electrode, that is a, we can use of a, if we go with the practical we can see that is the tungsten electrode. We are using that one inside the that torch. Okay, coming class will discuss. Okay, coming slides. Okay, now the providing a long electrode of a life for the of a high production of a requirement here, even with the variety of operation of a ranging from the high volume of a welding of a strip of a metal. If I say here, see from the diagram here, from the diagram there will be having a weld metal, weld pool, base metal, welding rod, tungsten electrode. Inside that one is a shielding gas and a gas nozzle, construction of a orifice, plasma gas, and a shielding. So here, if I'm saying here of a example, where I'm said that of a, there will be a hot ionizing of a gas. We are converting, that means we are heating that gas so that it will be a it will form into plasma. Means we are means it will be a changing of a temperature form of a, it will require a temperature of a 25,000 degree to 30,000 degrees, and here DC supply to get a stable arc welding here. Electrode we are giving a connection with a negative and a workpiece with a positive here, just like of a TIG welding. Electrode I am giving as a negative and the workpiece I am giving a positive here. Means here what happened here, I am giving a, here the workpiece is a positive connection with the base, okay, with the electrical, okay, positive, and here I am giving of a electrode, tungsten of electrode, I am giving a, this to a negative. So this is as per just like of our TIG welding here. And gases we are using of a argon, helium, nitrogen, we can go with the mixture also. Gases means here shielding gases. The shielding gases we can go with the argon, helium, and nitrogen. We can go with the mixture of that one. So we are using of this shielding gas here, which is, if I said also what I am saying, the shielding gas is simple thing which is protect from the atmosphere, which should not be contaminated with the workpiece here. But here the nozzle, see this nozzle here, Nozzle is a very important point here. Is the tungsten which is covered with the here of a here. This is a nozzle. Okay, this nozzle, gas nozzle. See this one. This nozzle. This nozzle is very important because it can be withstand that one. And this nozzle is a 90 mainly made up of copper here, and which is having a small orifice here. Means small area is there. And here we are saying of a transfer arc. Another one is a non-transfer arc. Means there is a two types of things are there. Transfer arc type. Another one is a non-transfer arc type. Means here what happens? There will be a transfer arc. Means there we can also say there is a transfer is also known as pilot. Sometimes they will ask you transfer arc is also called as a pilot arc also. So here what happened? How it is can be means gas is heated. Means here between the electrode and the nozzle. Here the gas gets heated here of a between the electrode and the nozzle here. The gas gets heated. That is a transfer. Non-transfer means below that one means it will be a the gas is means of it will move this area we can say to the non-transfer from the this nozzle to the workpiece here. So this gas is that is a non-transfer of a type we can say, and we are very well known that if I say of a uh, call it as a arc means here the weld pool, weld metals, base metals here. So these all portions we are saying. Okay. Now coming to the see here. See from the plasma is a means very basic point here. Just now I said it will be a ionizing. Okay, means we are heating the gas so that it will be a to get is a converter gas into a plasma. So that is the saying we are saying plasma is a ionized gas also. Just now first what I said of a hot ionized gas. Okay. So here we are using of a transfer type and the non-transfer type here. Okay. So it's clear now. Means here is I'm giving a connection to the terminal here. The electrical is passing from this one of a base metal. Another one is the electrode here. So here what happened? I am keeping of a plasma. This is the tungsten of electrode here in between that one. See this one. This is called as a tungsten electrode, which is covered with a nothing but a here with a one small of a copper here. Or after that there will be covered with a nozzle here. So here what happened? The nozzle is made up of a copper here so that it can withstand of this one. So here the tungsten of electrode, that is the tungsten of electrode. We know very well that is a non-consumable of electrode here. It is a non-consumable of electrode here. The nozzle it is made up of copper here. Okay, and here we are supplying of a shielding of a gas which is also a, so that it is protect from the atmosphere. When this process take place, even we can use of a welding rod here also. Okay, that is depend upon thickness of that one. And here is a constructing of a orifice which is a nozzle here. Okay, and the plasma gas which will form in between that one. In between the plasma gas will be a form here. Okay, so this plasma gas will form means it is between the electrode and the nozzle, that is a transfer type, and below of a nozzle to the workpiece, that is a non-transfer type we are saying. Okay. So here we can use of a gases. If I say of a gases, just now I said of a argon, helium, and nitrogen, we can use that one. Okay, the very basic point here. Okay. Now coming to the our next slide. Means here we are saying of a keywords of a means plasma, pilot arc, keyholes, and sinter, and a weld bead of a geometry here. Means the plasma, we know that one is a very high temperature. Just now ionize, that is a 25,000 to 30,000 of a temperature we are maintaining to ionize that one of a gas. Okay, that is a plasma we are saying. And the pilot arc is a first arc between the electrode and the nozzle. Just as I said of it, the pilot arc is also a transfer arc also between the electrode and the nozzle here. And the keyhole is a welding technique in which a concentrated of a heat source of a presenting the workpiece forming a hole at the leading edge of the molten point. Just now with the keyhole. We'll get off here. Okay. That is one. this area we can say. Now sintering the solid or a porous of a mass by means of a heating and a weld beaded of a geometry we can also with welding with height and the reinforcement and the depth of penetration here. Equipment just now from that one we are using of a open circuit of a voltage. See from this one. See from here power supply just now I said of a tungsten of electrode. One is connected to electrode, another one is to the workpiece here. In between inside that one we are using of a plasma gas. It may be arc, it may be argon, helium, or nitrogen we can say, and a nozzle here. Okay, nozzle is made up of copper here so that it can withstand that of a and a cooling after immediately it gets of a solidify here and shielding gas we can use that one. Okay, plasma gas. This is a plasma gas. Sorry, this is a shielding gas which I said argon, helium, and nitrogen here, and the plasma gas will be formed here. It will move forward here. Then welding can be occurred. And the current we are using of a 50 to 300 degrees, and DC just now I said of a just talk of a TIG welding here, and here the welding torch non-consumable of a just also. When I'm using of a tungsten of electrode means it is a non-consumable of electrode we are using here, and the cooling system water recirculating here, plasma welding torch here, plasma gas means argon, helium we can say, or a nitrogen here given of a hydrogen also. So we can mixing of that one also we can go ahead. Okay, nitrogen also we can use here. Now we can go with the another is a how it will work. Tungsten electrode has a negative polarity, just of a negative polarity which is giving that one, and the workpiece with a positive. Just now in a slide I said electrons flow to the workpiece here. So because we know that a plasma is with a combination of a atoms, electrons. So here with the ions. So this all are combination just now of a plasma. Which here is a plasma consists of electrons, ions, neutron particles have disorder violent of a movement here. So the molecules are particularly disassociated and the atoms are ionized here. And with the collision with the workpiece surface, they give the energy to the workpiece and the recombine means it will be here. And here the jet delivery of a narrow and the constituted of a plasma. So here we are saying how the type means types of a two types of a plasma. This I said of a transfer plasma and the non-transfer plasma. Very important point here. If I'm saying of a transfer plasma means arc is established between the electrode and the workpiece here. Okay, non-transfer is established between the electrode and the nozzle here. In the same manner, what happened? There will be having a electrical circuit. Workpiece is a part of electrical circuit here, and heat is obtained from the anode spot here, and workpiece is not a part of electrical here. Because what happened here? We are using of a gas flow, copper nozzle, and constructing of a orifice and plasma gas. So there is a workpiece is not a part of non-transfer of a plasma here. Okay, if a high penetration is obtained here, or a thicker sheet can be welded here, less penetration is obtained here, so thin sheet can be welded. Now in a two modes of operation in a plasma arc welding here, melt in a mode in a keyhole of a mode. So what happened? Melt in mode here is a when energy is a transfer, energy is a goes to transfer from a workpiece from the plasma arc. The energy strikes the surface means the of a gas is strike the immediately cause of a heating. Means the gas what happened which is moving a plasma gas is striking on the workpiece it gets of a heating. Sometimes it gets of a melts here. Okay, then is formed for the welding here. And due to the combination of a conduction of a heat of the arc and the conversion of a kinetic energy it takes place here, and it will be of a conducted away at the temperature and will also rise and the cause of melting and produce of a fusion of a weld here. Okay, and this mode of energy is means we are saying that the melt in a mode we are saying, or a conduction mode also we can say. And the keyhole mode is a if a density of energy is a from the plasma arc is very high, so we are saying that is a loss by the conduction in a workpiece. And we can also the plasma arc can penetrate the molten pool and form a small throughout the hole in the well. So we can also say if I say of a here, if not using of a, we can also some another process I said of a plasma arc cutting also we can go that. Okay, but we are saying of a plasma arc welding, so we are going with this all things. Okay. So the moving of a welding of a means if you go with the more heat, so what happened? The welding is penetrate can be taken place here. What are the welding bolt and pulley here? that is the plasma due to of a high of a temperature we are using that one. Even with the molten and the metal of a surrounding the keyholes to the rear of a region where it is a re-solidified to form the weld grid and the keyhole mode in a plasma arc of a welding here. Okay, larger penetrations are the melt-in mode here. And effect of a various factors on the weld quality, instability of a keyhole, nozzle shape and the size, tungsten electrode of a setback, uh, composition and the flow rate of a plasma of a gases here. So this all comes in this one. Okay, means effect of a various factors on the weld quality here. Okay, that is depend upon the keyholes, nozzles, and the tungsten electrodes and the flow rate of the plasma gas. This is and welding current, welding speed, and distance of a nozzle to the this is standoff distance should be with some maintain some distance from the nozzle to the workpiece here. It is also having a approximately it will be distance should be a T to 12 mm. We are saying that's in terms of a standoff distance also sometimes means there will be distance of a nozzle and the workpiece here. Okay, and the features of a this one is a protect the electrode and the low means of a welding of a capability and a arc consistent and a generally of a arc started here means we can say the higher productivity we can say lower degree of a deformation also we can say here of a work and needs a these are the things can be taken place here and a temperature just now I said of a year and a weld times of a shots of a can be taken place is a 0.005 of a seconds. It can be taken place here. Length of arc benefit due to a arc shape and even heat of a distribution. Diameter are chosen to a nozzle orifice here. And the advantage control and the quality, more freedom of during the manual welds, faster travels of a speeds here, keyhole effects, lesser angle of a distortion here take place here. These are take place in of a means of advantage of a here. Now coming to the disadvantage here is a greater inputs means that the another is a we can say here the disadvantage is a needs expensive equipment here and here operating means of a very difficult here sometimes it is a very difficult here. Okay, operating system is somewhat very difficult in this is also one complex and a costly here more specialized of a welding process here bucking of the torch here because due to the here more specify of a welding process means due to ultraviolet and infrared radiations here also. Okay, these are the immense applications is a small parts of a welding can be taken place shielded components here tool and die and the mold repairs and the tube millers welding and the long strip of a metal of a welding can be occurred can easily take place here that is a we can go with the applications here. Okay, and especially this type of things that take place in aerospace of industries very well. Thank you and have a nice